welcome back to Watobe. We are starting this week with statistics. So this is just a very short course because statistics is not a big part of paper 2. As I'm sure you're all fully aware now, questions on statistics are the very first questions that we get in paper 2. And the new work in matric involves scatter plot and the equation of the least squares regression line and the correlation coefficient. I will obviously discuss these with you. It's not going to take me very long to do so. So I'm going to do that in our third lesson. I just wanted to spend some time revising what we need to know from grade 11 because these are easy marks. So theoretically, when we approach these questions, we really are wanting to get full marks for any questions on mean, standard deviation, box and whisker plots, outliers, cumulative frequency, ogives, etc., etc. Okay, so just a bit of revision from grade 11 then today and then on Thursday, where I will speak in more detail about cumulative frequency and the ogive, the graph of the cumulative frequency or graph of cumulative frequency. Okay, so the example that I've chosen this evening to kick us off basically covers a whole lot of things in one. First of all, what they've done is they have obtained information about the Comrades Marathon, and there's a little bit of a story here, but the idea is that the table summarizes the athletes that have achieved the most wins to date in the Comrades Marathon. So Alan Robb won 4 times, Arthur Newton 5, Bruce Fordyce 9, Elena Nurgalieva 7 times, Frith van der Merwe 3 times, Hardy Bellington 5 times, and then they've also got some other people on the other side. Helen Luca 3 times, Jack Meckler 5 times, Letty van Zyl 3, Maria Buck twice, Maureen Holland and 4 times, and Wally Hayward 5 times. They ask us, first of all, to calculate the mean for the data. So I just wanted to remind you how we calculate the mean using our calculators, right? So the first thing that you want to do is go to your mode button, all right? And you're going to choose the statistics option. So you choose option number 3, okay? Then you would choose option number 1, 1-VAR for variance. So you choose number 1. And now what we're going to do is we're going to enter all the pieces of data one under the other. In order to go to the next line, you would press the equals button. So I'm going to press 4, and then I'm going to press equals, and then 5, and then equals, and then 9, and then equals. You do this on your calculators as well. I'm just demonstrating on the emulator, which I'm very proud to have. So I've got 6 pieces of data. Has everybody got that in their own calculators? Do this yourselves on your own calculators. So remember, press mode, go into number 3 for statistics and choose option 1, variance. Enter all of these values, pressing equals after each one. And after we have done that, we press AC, shift 1. Okay, AC, shift 1. Okay, and then I want to go into number 4, into variance. So I'm going to choose option number 4, right? So the values that are of importance to us is going to be number 2 and number 3 that you see on the calculator in front of you. All right, so the symbol for the mean, if you guys recall, the symbol for the mean, sorry, that goes away when I write. The symbol for the mean is this. Okay, so that's the mean. And the symbol for standard deviation is this. That's standard deviation. Come calculate. There we go. All right. Okay. I don't know why you can't see the calculator, Unati. Can everybody else see the calculator?
No, actually, no.
You
Not.
can't. Oh, okay. All right. Okay, hang on a second. Okay.
No,
I
I'm just not sure.
all right. I don't know. Sorry, here I am going, oh, meanwhile you guys can't see it. Okay, hold on a second. Let's just see if I can.
At this moment, what we're seeing is the standard
You're just seeing this.
deviation.
Oh, you've just seen what I've written. Okay, no.
Yes,
I
what
want
you
you
have
to see.
written.
Okay, all right. Just give me 1 second. I'm just going to find
Okay.
out why you guys cannot see my emulator. 1 minute. Okay, all right.
Okay.
Okay. Sorry, it's all okay. So, oops, now that's made it tiny. Let's put it over here. What's that button? Don't know what that does. What does that do? No, that doesn't help us either. Window. Tools, help. Actually, you know what I'm going to do? If I go back to new share, but then is it just that? I want to share. Hang on, here we go. Hang on. Let's just see. How about that? Now, can you see my emulator? Can you? Oh, yay, I figured it out. Okay, all right, here we go.
Yes, now we can see it.
Okay, sorry guys. I didn't share correctly. All right, so now I'm going to have to go back to the beginning. Okay, so let's just AC 93 equals, sorry, on 9 3 equals AC. Sorry, I just had to reset the calculator. Okay, so I figured, there we go. All right, brilliant. So I figured in order just to be able to do this with you, it's going to help to have an emulator on screen. So this is what we would do, okay? You're going to click on the mode button, and then you're going to choose option 3 for statistics. Okay, so you guys follow along on your own calculators to make sure that you can do this, okay? So we're going to choose option 3, which is statistics. For today's lesson, we want to choose option number 1, variance. That's where the mean and the standard deviation are. So we would put 1 in, and then you can see there is a column with an X, and we're going to enter all of the information that we see on the left. Okay, so the numbers. So I'm going to press 4, and then you guys are going to click on equals, okay? So 4 and then equals, 5 equals, 9 equals, 7 equals, etc., etc. So put all of those numbers in. And you should have entered 12 numbers. Everybody okay so far? Have you entered the 12 numbers? Thumbs up, thumbs down. Good, okay. So after we've entered the 12 numbers, we press AC, Shift, 1, and then we choose option 4. Okay, so AC, Shift, 1, and then choose option 4. Okay, now what we are interested in is what I was writing on the screen before you were able to see the emulator. All right, we want number 2 So the X with the line above it, that's X bar, and we want number 3. Okay, so what you would have to do is you'd have to press 2, and then you'd have to press equals. So rounded to 2 decimal places, that's 4,58. So the mean is 4,58. And then I'm just going to write down, excuse me, I'm getting sick. I'm just going to write down the standard deviation at the same time instead of re-entering all the information again later. That would be silly for me to do that. So I'd have to go AC, shift 1 again, back to 4, and now I'd have to choose option number 3 and then press equals. So again, I want to round that to 2 decimal places. So that would give me 1,85. Okay, 1,85 is my standard deviation. 1,85. Okay, is everybody all right with how to find or how to calculate the mean and the standard deviation on their calculator? Is this something that we can say we can do now?
I hope we all get it, because this simplifies life.
Yeah, it made life a lot easier. I wish I'd had this when we were doing financial maths. Okay, so Letabo says yes, Lebohang's happy, Nolwazi's happy, Mamelo, you are not happy, Leanne is fine. Okay, so just for, if you would just be patient, Matrix, I'm just going to do it one more time in case there's anybody who is stuck. Okay. Okay. Okay, so there's 2 people saying please. All right, guys. So if you would just let me explain this one more time. If you are in a big hurry and you want to carry on with the questions, you're welcome to start answering question B and question C if you want to. Otherwise, if you could just wait 1 minute, let's just go through it again. Okay, so it's not difficult. It's just a lot to remember. Okay, so we have to press the mode button and we have to choose option 3 for statistics. Then choose option number 1 for variance. And now you enter the data pressing equals after each number. Okay, so I'm going down the columns. I'm going to press 4 equals, 5 equals, 9 equals, 7 equals, 3 equals, 5 equals. And then the next column, 5, 3, 2, 4, 5. Okay, I'm going to enter all the data like that. There are 12 pieces of data, and that's why I'm on row 13, because I've entered 12 pieces of data. Now you press AC, shift 1. And we want to choose option number 4 for variance. When we get inside here, it's option 2 for the mean and option 3 for the standard deviation. So you'd press 2 and then equals. There is your mean. So you'd round that to 2 decimal places. Yes, Stokozile, you're welcome to unmute and ask.
You're still muted, Tokozile. You must unmute and then you can talk. At this moment, there we go.
Can you please repeat question A? I don't understand.
But that's exactly what I am
The
doing.
one for
I've repeated it again now. All right. Okay, I'll do it one more time, but then unfortunately I'm going to have to move on, okay? So please make sure you've got your calculator with you so that you can follow what I'm doing, okay? Otherwise, everybody else is waiting for us and we're not moving on, all right? Okay, so let's go back.
Yes, ma'am.
Okay, thank you, my darling. All right, let me just clear it again. Okay, So everybody, we're going to press the mode button. Then we're going to choose option number 3 for statistics. Then you choose option number 1 for variance. Now we're going to enter all our information. All right, so the numbers that you see here, so these numbers here in this column, this is what you're putting into the calculator. After each number, you're going to press equals, okay? So you're going to press 4 and then equals, and then 5 and then equals, and 9 and equals, and 7 and equals, and put all those numbers in, pressing equals after each one. Okay, and then you get to a point where it looks like, okay, all right, now you press AC, Shift 1, AC, Shift 1. And then you've got to choose option number 4, option number 4 for variance. Okay. All right,
Yes,
and now, good. And now to get the mean, you're going to press 2 and you're going to press equals. There's your mean. Okay, and I wrote it down over there. There's the mean. And then while we have this information on our calculator, we want to just write down what our standard deviation is. So now when you want to go back and get your standard deviation, you press AC, Shift 1. You got to do all of this again, unfortunately. 4, and then you press option number 3 for standard deviation. So I press 3 and I press equals, and then there's my standard deviation rounded to 2 decimal places. Okay. All right, so the mean for the data in part A, we've done together. So our mean is 4,58. And something like this is generally for 2 marks. It would be 2 accuracy marks for calculating our mean. The mode we would work out not using our calculator. What does the word mode mean? Do you remember? The mode. What does the word mode mean? Not the middlemost number, Amahle. The one that appears the most. That's it. Okay, Gugu, quite right. Okay, I agree, Leanne. Okay, it's all right. Yes, the number that appears the most. Okay, so as Leanne has put in there, the mode would be 5. Okay, that's the number that comes up the most number of times. Okay, the number 5 comes up 4 times. So it's the number that comes up the most frequently. The mode is the most. Okay, so mode is the number that we see the most. Okay, the median is the one that's in the middle. Okay, and then your mean is your average. Okay, so in other words, you've added all the numbers together and divided by how many numbers you've got. Okay, so just a reminder about what those things mean. Okay, now they want us to draw a box and whisker plot. When we draw a box and whisker plot, there are a few things that we need. First of all, your box and whisker plot comes from a set of data called your 5-number summary. So your 5-number summary consists of 5 numbers. That's it, Leanne. Quite right. Okay, so your minimum, Q1, which is your lower quartile, Q2, which is your median, Q3, which is your upper quartile. You guys are getting back into this again. And number 5 is your maximum. Okay, so what we would need to do is go back here, and that's it, quite right. Okay. In order to get your lower quartile, your median, and your upper quartile, the data needs to be put into order. So we're going to have to do that as well. All right. Maybe we should do that first. Okay. So I'm going to put the data into order over here. What is the smallest number? What is my minimum going to be? My minimum is My minimum is 2, quite right. Okay, so there's my 2 over there, and I'm going to strike it off to know that I've got it. Now I'm going to write down my 3s. So there's a 3, and here's another 3. So let's get that down. And then another 3. So let's get that down. Have we done all the 3s? It looks like we have. Okay, and then there's a 4 here. And there's another 4 over there. So we'll put those down. And now let's put down the 5s. Remember, we had 4 5s. 1, 2, 3, 4 of them. So let's get them down. And what's left over? A 7. And the last one is a 9. Okay. So the 2 is our minimum. So our minimum is 2. The 9 is our maximum. So that's going to go over there. All right. Now we have 12 numbers. If we count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So your median is positioned in the middle. Okay, so the middle number, 1, 2, 3, 4, 5, 6. Your median is in here. 1, 2, 3, 4, 5, 6 to this side, and 1, 2, 3, 4, 5, 6 to this side. So your median is between 4 and 5. So when there are an even number of numbers, like there is in this case over here, because there are 12 numbers, we would have to take the mean of the 2 middlemost numbers to get our median. So we do that. So our median is going to be 4.5. Our lower quartile, so let's just draw so this over here with the purple block around it, that is your lower half. That is your lower half. Again, if you want to find your lower quartile, that's it, that's right. If you want to find your lower quartile is going to be between 3 and 3. So 3 numbers to the left and 3 numbers to the right. That's where our lower quartile is. So with our lower quartile, we need to do the same thing. We would add 3 and 3 and divide by 2, and that would be 3. And our upper quartile is the same story. Our upper quartile is in between those 2 numbers over there. 3 to the left, 3 to the right. That's where our upper quartile is. So our upper quartile would be found in the same way, 5 plus 5 divided by 2, which gives us 5. So now we have our 5-number summary. We can draw our box and whisker plot. Now, when you draw a box and whisker plot, you have to draw it over a ruler or a scale. All right, otherwise it's incorrect. So you're going to look at your minimum, you're going to look at your maximum, and we're then going to choose a scale. So in this case, I wonder if we could use this ruler. Let's just see. Okay, I'm not liking what that's doing. It doesn't matter. All right, let's do our own line. Okay, we'll do that. There we go. And we can use the blocks that we've got on our screen. So we can make that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We didn't even need it to be. Okay, so Amahle, that is because in your upper half, these are the two middlemost numbers. Okay, there are 6 numbers in your upper half. There are 6 numbers in your lower half. So that's why you'd have to say 5 plus 5 over 2 for your upper quartile, in the same way that you'd have to say 3 plus 3 over 2 for your lower quartile. That's for grouped data, and you will never ever have to do that, Gugu, when you are working with a cumulative frequency. Okay, so we'll talk about that when we have our lesson on Thursday. All right, so you never have to use that. Those formulae are only used like in real world situations where you're dealing with millions and millions of pieces of data. Okay, so you don't have to do it like that. If you want to find the median, you just go halfway. If you want to find the lower quartile, it's a quarter of. If you want to find the upper quartile, it's 3/4 of. But I'll explain that to you when we do it. All right. Okay, so I've made my line too long, but I'm not going to worry about changing it now. So there's 1, there's 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we want to do it again, you guys would use a ruler here. I'm going to put a line over my minimum. I'm going to put a line over my lower quartile. I'm going to put a line over my median. I'm going to put a line over my upper quartile. And then I draw a box around the quartiles. And now I'm going to put a line over my maximum. And then I get my ruler and I connect the whiskers to the box. Okay, and there is your box and whisker plot. Okay, everybody happy with that? Any questions? Good question, Manentle. Is it skewed to the right? It is. Okay, it is skewed to the right. And that's what they want us to do here, is they want us to comment on the distribution in terms of skewness. So you are quite right, Manentle. It is skewed to the right. We can also say positively skewed. Okay, so it is positively skewed. So there's a long tail on the right-hand side, so that's why it is skewed to the right. If it was the other way, then we would say that it is skewed to the left. Yes, absolutely. Okay, good. Well done. They will ask you questions about skewness, so it is important that we are able to answer that. Okay, the standard deviation is the next question, question E. We've already calculated the standard deviation. All right, so in question E, we've already got it because we did it in the beginning. Our standard deviation was 1,85, right? So before we move on, what does standard deviation even mean? When they tell us to calculate the mean, they're telling us to calculate the average. So the average number of wins by any one athlete. What is standard deviation? Yeah, it's interesting. We know how to calculate it using our calculators, but we don't really know what standard deviation means. Okay, so standard deviation is the average. Well, let's see if somebody says, there we go. Okay, let's harbor good. So is it how far the data values deviate from the mean? It is. All right, so it's how far the data values are from the mean. Quite right. How do they deviate from the mean? How far are they from the mean? Excellent. Okay, Latabo, very nice. And it's important that we know that because they could ask us an application type question based on what standard deviation is. All right, and in fact, no, not the spread of the data. Okay, so the spread of the data mind you, I'm just thinking about that, Lebogang. Yes, I suppose we could say that is the spread of the data around the mean. Yes, absolutely. How the data is spread around the mean, how far the points are on average from the mean. Yes, sure, not wrong at all. All right, so after calculating the standard deviation, they then ask us how many athletes lie outside the first or one standard deviation from the mean. Okay, now this is also a commonly asked question. How many athletes lie outside one or the first standard deviation of the mean? So this is what we have to answer a question like that. First of all, we have to take our mean and subtract one standard deviation. That will give us our lower bound. So we know that our mean, we've calculated up here, is 4,58. And we're going to minus one standard deviation. Okay, so on your calculators, you're going to say 4.58 minus one standard deviation of 1.85, and your lower bound is 2,73. We do the same thing, only now we add one standard deviation. So now we're going to say 4.58 and we're going to add 1.85. And that's going to give us 6,43. That's it. Okay, so one standard deviation from the mean at the bottom end is at 2.73. One standard deviation of the mean on the upper end is 6.43. Yes, Amahle, you're welcome to unmute and ask.
Good evening, ma'am.
Good evening, Amahle.
Ma'am, why exactly do we use the form? Well, not exactly the formula, but like, why do we do it the way you do it in question F?
Because they're asking you to work out. I haven't finished yet, but they're asking us to work out. I haven't finished yet. I'm finding my upper and my lower bound. So what I'm trying to do is I'm saying, here's my mean, okay, my average. One standard deviation smaller than that is this number 2.73. One standard deviation bigger than this is the number 6.43. So now what I'm going to go and do is I'm going to go and look at my data, right? Let's rub this out so we can clearly see all the numbers here. How many of these numbers are smaller than 2.73? How many numbers are smaller than 2.73? There's only one of them, isn't it?
Yes.
Okay, so that's this one over here. That's smaller than 2.73. Now I'm going to go back and I'm going to look and I'm going to say how many numbers are bigger than 6.43. So that would be this number over here and that number over there. All right, so 2 is smaller than 2.73 and 7 and 9 are bigger than 6.43. So to answer the question, how many athletes lie outside the first or 1 standard deviation from the interval, there are 3 athletes.
Okay, that makes sense.
Okay, does that make sense?
Mm-hmm.
Okay, 1 was smaller and 2 were bigger. Okay, Matrix. All right, anybody else got a question? I know that was confusing for Michael. Anybody else want to ask a question? Have you seen this before? You should have. You should have seen this in grade 11, but I mean, it's obviously been a long time since we've done that. Okay. Sure, Lindelwa, not a problem. Okay, so I'm going to go up again. All right, so Maria Buck won twice. So that's the only number that's smaller than 2.73 were her 2 wins. And then bigger than, what was it, 6.43 was Elena and Bruce on 7 and 9 respectively. Okay, so there were 3 athletes that lay outside of 1 standard deviation of the mean. All right, so if they ask you to calculate how many pieces of data or how many athletes or whatever it might be that lie outside of 1 standard deviation of the mean, you would need to find your lower bound by subtracting 1 standard deviation from the mean, your upper bound by adding 1 standard deviation of the mean, and anything smaller than the lower bound or bigger than the upper bound would be the answer to your question. All right, so Stokozile is because there is that long tail on the right-hand side. Okay, that's why it's skewed to the right. This long tail here means the data is skewed to the right. So in other words, the data is bunched up down here at the bottom. And then there's a big gap between where the data is concentrated and your maximum value. Okay. So wherever your tail is, that's what it's skewed
Yes.
to. Okay, Stokozile?
Yes, ma'am.
All right. How did I get the 3? You mean this 3 over here? The 3 athletes that lie 1 standard deviation of the mean. So I went and I counted up here. All right, so Maria Buck had 2 wins. 2 is smaller than 2.73. And Elena and Bruce had wins of 7 and 9 times each. That was bigger than the 6.43. So there are 3 athletes that lie 1 standard deviation from the mean. Okay, so you'd go back and you'd count them. Okay, any other questions? Awami, remember we worked that out in the beginning. Okay, the 1.85 was our standard deviation. We did that in the beginning on our calculator. Yes? Awami? Do you remember now at the very beginning? Okay. All right. So I know they didn't ask us to do it right down in the beginning, but I mean, it's silly for us to, no problem. It's silly for us to calculate our mean and then not do our standard deviation at the same time. All right. So if they ask you to calculate the mean, just write down what your standard deviation is at that time, and then you can put that answer in where they ask you for it. Okay. All right. Now let's go and have a look at the last question that they're asking us here. Okay, and this is, why is Bruce Fordyce's number of wins an outlier? Give a mathematical reason to justify your answer. So I wanted to do this question because I wanted to revise with you how to calculate whether something is an outlier or not. Okay, so we can't just say because a number is different to the others that it's an outlier. An outlier is something that is calculated, again, according to a specific method. All right, so when we want to calculate one standard deviation from the mean, we would do what we did in F. If we want to calculate whether something is an outlier, we do the following. Okay, so I'm going to do question G over here, and I'm just, so this over here was one standard deviation from the mean. That's what we were calculating there. And over here, it's calculating an outlier. Okay, so an outlier is a value that is very, very different from all of the others. Okay, so to calculate an outlier, again, if it's smaller than a certain value, it would be an outlier. If it's bigger than another value, it would be an outlier. All right, so if in order to calculate whether something is an outlier, so smaller than, so the smaller than part works as follows, okay? You would have to take your lower quartile, all right? And from that, you would subtract 1.5 times the interquartile range. So if your value is smaller than the lower quartile minus 1.5 times the interquartile range, then it is an outlier. Okay, so in this particular case, all right, we're not working with that. They want Bruce Fordyce's, so that would be greater than. So to get any value greater than, we would take our number, and it would need to be bigger than your upper quartile plus 1.5 times the interquartile range. Okay, I don't know if you remember doing this in, I think you would have done it in grade 10 the first time, how to calculate an outlier. So let's go and have a look. Remember, we've got our upper quartile from here. It's 5. So our upper quartile, we worked out, was 5. Our interquartile range is Q3 minus Q1. So your interquartile range is Q3, your upper quartile, minus your lower quartile. You always use 1.5, yes. So in this case, we would say 5 minus 3, and that would give us 2. All right, so let's have a look. We're going to take our upper quartile of 5, and we're going to add 1.5 times our interquartile range, which is 2, and we're going to see what that gives us. Work that out and tell me what you get. Exactly, we get 8. All right, so any number bigger than 8 would be an outlier in this data. Okay, so that's why when Bruce Fordyce won 9 times, that's why it is an outlier. Okay, so 9 in this case is going to be bigger than our upper quartile plus 1.5 times our interquartile range. Okay, so therefore Bruce Fordyce is an outlier. Okay, does that make sense to everybody? Are there any questions? No questions, you sure? I can do the smaller one, absolutely. Okay, so I don't think we'd have anything in this case, but let's do it. All right, so our lower quartile was 3. Okay, so Q1 was 3. Our interquartile range is the same. It's still going to be 2. So what we're going to do is we're going to take our lower quartile and we're going to minus 1.5 times your interquartile range, which is 2. And I think we might end up with a negative number here, but that's okay. So 3 minus 1.5 times 2. Oh, it gives us 0. Okay, 0. Okay, so there's no number smaller than 0 in our data. Okay, and if there was, I mean, it wouldn't make any sense given the data that we're dealing with. But if anything was smaller than 0, then that would also be an outlier. Okay, so these are methods that you guys need to learn. Okay, because obviously it's not going to be on a formula sheet that you can go and look up. All right, same with this one over here, where you calculate how many pieces of data lie a standard deviation from the mean. Okay, that's not going to be on your formula sheet. So these methods we have to learn in order to be able to answer these questions. Right, so I've done the smaller one, I've done the bigger one. Any other questions before we move on? So why is Bruce's number an outlier? Because Lindell, it's bigger than 8. Okay, so we calculated the number that was the upper quartile plus 1.5 times the interquartile range. That's what I was doing over here. And I got that number to be 8. So anything bigger than 8 is an outlier. Okay, it's mathematically an outlier. Okay, so that's how you would do it. All right, any other questions? Are we all good, everybody? Thumbs up, thumbs down, how are you feeling?
Yes, would like to know how you're feeling. This is some interesting thing, guys, and it's all knowing what you have to do, and that's it. Not
Yeah.
to know anything.
So Michael is happy. Okay. Everybody else? Okay. All right. Okay. All right. So I have got this question for you. I imagine this will probably take us till the end of our lesson. Let's see if we can do these and we'll mark it quickly before the end of the lesson. I'm hoping, I know this may be not fair of me, 3, 4, 5, 5 and 4 is 9. Okay, so we might just run out of time. Maybe what we should do is see if we can do this together. Right, so hopefully they give us a nice easy question like this as our first question in trials. This comes out of a trials paper, so we'll have to wait and see. So the following information represents the number of ins scored in 15 innings by a cricket player during a season. And if you have a look at the numbers, you can see that they have already been put in order from smallest to biggest for us. Okay. The first thing that they want us to do is calculate the median of the data. So how do you think we're going to do that? Now, look, it's only out of 1 mark. How are we going to find the median? The one in the middle. Remember, the median is the one in the middle. Can anybody tell me what they think the median is? It's easy when it's an odd number of pieces of data. The one in the middle. Okay, so the one in the middle, quite right, is 55. Okay, there are 7 numbers that are smaller than 55, and there are 7 numbers that are bigger than 55. Well done. Okay, so the median in this case is 55. We didn't have to add anything together and divide by 2 because there were 15 numbers. Okay, so it was easy to identify the one that was in the middle when we have an odd number of numbers. Good. All right, lovely. There's our first mark. Now they want us to calculate the mean. Okay, so now I want you to do what we practiced on our calculators. Okay, there's our emulator. You guys try and calculate the mean quickly, and you could share with me what you've got. Okay. Some answers coming through. Okay, and then you can do the standard deviation. If you've got that already. I'm just behind you guys here. Okay, I'm getting the same as you guys, 55,2. Awesome. All right, so we get 2 accuracy marks for that. Good job, everybody. All right, let's see what we're getting as our standard deviation. Okay, so I'm getting 20,50. What are you guys getting? Let's see in the chat. Ah, there we go, 20,50. So just be careful, Gugu. All right, because there's a 7 in this third place. That 7 is going to push that 9 up, and the 9 is going to push the 4 into a 5. Okay, so it would be 20,50. So writing down the standard deviation. Standard deviation. There we go. All right, so 2 marks for that. We're all smiling. Good, everybody's happy. Now, they've said calculate the percentage of innings that lie 1 standard deviation of the mean from the number of runs scored. Okay, so they're just asking us to take things 1 step further and do a percentage. All right, that's not a difficult thing for us to do. So we all know how to calculate a percentage, don't we? All right, so let's so 1 standard deviation from the mean. So that means we need X bar minus 1 standard deviation. So that's, well, let's do this together. So we would have 55,2 minus 20,50. So that gives us 34,7. Are you guys getting that? Yeah, there we go. Well done, everybody. Good. 1 standard deviation above the mean. So that would give us 55,2 plus 20,5. That gives us 75,7. Okay, so now remember, we've got to go and see how many numbers are smaller than 34.7. So now we count them. Okay, 1, 2, 3 numbers are smaller than 34.7. What's bigger than 75.7? 1, 2, 3, 4 of them are bigger than 75.7. So the blue ones, there are 7 numbers. So 7 numbers, this is how we calculate our percentage now, matrix. Okay, 7 numbers out of 15 are, oh, sorry, lie within 1 standard deviation of the mean. Sorry. I didn't read the question properly. Sorry. Okay, so within 1 standard deviation of the mean means, okay, so between, so now they're asking for between these two, between 34.7 and 75.7, not outside of, within. Sorry, one must read the question properly like I had done. Okay, so within, so it would be this one and 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 not that one. So 1, 2, 3, 4, 5, 6, 7, 8 of them. 8 numbers out of 15 are within 1 standard deviation of the mean. Calculated as a percentage, we'd have to multiply that by 100. So 8 out of 15 times 100 gives us a percentage of 53,53. Sorry, 53,33. Okay, everybody getting that? Why not 33? Okay, because 33 is smaller than 34.7. So remember here it said the calculate the percentage of earnings that lie within 1 standard deviation of the mean. So not outside of, like the previous example, within. Okay, so it can't be smaller than 34.7 and it can't be bigger than 75.5. Okay.